page look familiar? It should. This notebook page was the very first page we started looking at and working on when we stopped with our atomic theory lessons and started looking into compounds and mixtures and solutions. This was the very beginning of our unit. See how page 49 is highlighted? That's how we know. All right, we're going to start reviewing for the test here. And so I want you to make sure that your notebooks are open. I'll give you a second to get them out and have page 49 in front of you. Okay, so you should have compound, and a definition is a pure substance composed of two or more elements that are chemically combined. You should have a definition of mixture, two or more substances that keep their original properties and do not combine chemically when put together. You should have made 4 boxes with different models in them and labeled each of them with the word compound or mixture. This is a mixture. It has a compound and element. This is just a compound. These are all the same molecules. So we have mixture and compound. This is just a compound. They're all the same compound. This, we have all different kinds of molecules in here, so this is a mixture. Do you have any questions about compounds or mixtures or elements in these diagrams? Okay, let's turn to page 50. Let's see if I can get this lined up. Right. Okay. On page 50, I asked you to be able to identify a model to describe the atomic composition of simple molecules. So our definition of molecule is a group of atoms bonded together, representing the smallest unit that can take part in a chemical reaction. This one looks like water, and I asked you to label it with the correct chemical formula. So this is H2O. Big H, little 2, big O. This one is carbon dioxide, has 1 carbon, 2 oxygen. This is CO2. This one is ammonia, and you can label it with nitrogen, hydrogen, hydrogen, hydrogen. So 1 nitrogen, 3 hydrogens, NH3. So capital N, capital H, little 3. Okay. This one is methane. 1 carbon and 4 hydrogens. It's C, capital H, and a little tiny 4. Hope you guys got those right. All right, let's turn the page. Then we went on to talk about heterogeneous and homogeneous mixtures. Remember, this would be a heterogeneous mixture, and this would be a homogeneous mixture, right? All different things, all different sizes, all of the same. It looks the same, okay? So hopefully you understood that a homogeneous mixture is made of different substances that are uniformly distributed throughout the mixture. It means they look the same and they're distributed equally throughout the mixture. Those BBs actually are. Homogeneous mixture, 2 or more substances that remain physically separate. You could pick each one of these out physically and you could separate them pretty easily. All right, page 52. Page 52 says, I can classify mixtures as homogeneous or heterogeneous. Hopefully you figured out the answers to this one by using your resource documents. So let's just go through really quickly, and I'll tell you whether it's a pure substance or a mixture, and then whether or not it's an element or a compound or heterogeneous or homogeneous. Milk is actually a mixture of water and milk. And it's a mixture, and it looks the same, so it's homogeneous. Iron is a pure substance, and it's an element. Sugar water is a solution, which is a kind of mixture, right? So it's a mixture, but it's homogeneous. That looks the same thing. Pizza is a mixture, and it's heterogeneous. Oxygen is a pure substance, and it's an element. Tossed salad is a mixture, and it's heterogeneous. Pure water is a pure substance, and it's a compound. Soil is a mixture, and it is heterogeneous, usually has chunks of stuff in it. Paint is a mixture, it's a solution. Paint is a mixture, and it's homogeneous, looks like one thing. And salt, NaCl, is a pure substance, and it is a compound. Do you have any questions about that page? Okay, just a quick note, a pure substance can be an element or a compound, but the composition does not vary. 53, please. On page 53, we started talking about solutions and their types of mixtures. Solutions have dissolving going on, and one is a solute and one is a solvent. Remember, solute is the substance that's dissolved, and solvent is the substance in which the solute is dissolved. Remember, if you have a solute, which is a smaller word than solvent, it's the smaller amount in the substance, okay? Let's look at page 54. This is the last page of our unit. It says, I can identify factors that affect how fast a solid will dissolve. We did a ton of labs for this. It was super fun. Or not, because we didn't actually do it. We watched some videos. But regardless, it was super interesting, right? So anyway, factors that affect how fast a solid will dissolve are mixing, heating, and crushing. Mixing, you can stir or shake it, and it just makes it the bonds break easier, it separates and dissolves. So heating speeds it up. The particles break apart more, they're easily, and they collide more often, and crushing increases the amount of surface area and contact between the solute and the solvent. So I asked you to list 3 to 5 examples of solutions here. Salt water, ocean water, sugar water, syrup, tea, coffee, all good examples. And describe what you learned in one of the labs, like more mixtures. Remember, that was the one we had, like the mixture with the dinosaur and the spiders. Or sweet solutions, and that was the one where you put a piece of candy in your mouth and trying to dissolve it, and how you made it dissolve faster as you stirred it and then you crushed it. And then the rate of dissolving, where we looked at what it was like to dissolve salt in either hot water or break it up into smaller pieces as opposed to just one piece and give it more surface area. Okay? All right, so today, my expectations for our lesson. You are going to make sure your notebook is up to date. Go over the study guide, okay? Then I want you to take the test. Please use your notebook. You can take it 2 times. You'll make sure that you substitute, don't substitute anything. I don't know why I said that. Make sure that you use your notebook or any other resources you need to go back and refer to a periodic table. You will need a periodic table. Maybe you'll need a periodic table. If you didn't memorize your symbols, you might want a periodic table, but you definitely need your notebook that you worked so hard on and you've been studying for 10 minutes a night, every night. You're going to rock the test and you're going to do awesome. So I'm expecting this. Have a good one. You're going to do awesome.